by having polylysine slides, okay, which can be either ready-made or you can coat polylysine on the slides in your own lab. With a diamond marker, draw a circle underneath. The circle is more a reference point for the cytogeneticist who has to locate that nucleus and to release the probes in a certain particular location for hybridization. As you know, the fish probes are very tiny in amount. You literally put 1 microliter or even less. So it needs to go in a very specific area. So you can't draw a very big circle because the probe is not going to be enough to cover that whole area. So your circle has to be quite small. So always label the slide in pencil, because if you use an alcohol-based pen, during the whole dehydration process, when they move the slides from 70, 90, 100 ethanol, the alcohol pen will wash off. So label it in pencil. So the way to label it is the patient's name and embryo number. Okay? So because we take 2 cells in our lab, we always put the 2 cells next to each other on the same slide. Okay, so you can see that the slide has got 2 circles there on the underside. First thing to do is
one slide per embryo.
1 slide per embryo. Yeah. So we've got 2 solutions here, what we call the spreading solution and PBS. The PBS is standard, what we get ready-made. Spreading solutions, how to make spreading solutions is in your handbook. The recipe is there. It's a combination of Tween, 1NHCl, and dilute water. Okay, so the recipe of how to make spreading solution is in your handbook. Again, spreading solutions are made fresh on the day. You can't make them a week before and keep them. The potency may be affected. Okay, so always make fresh spreading solutions per case, not even 1 lot for everything. Okay, so put a drop of spreading solution in the middle, then make a drop of PBS on the side. The PBS is there to wash your cell first and remove any oil that is there as a result of the biopsy dish. So you pick up your cell, first wash it in PBS, then in minimal carryover, release it in the spreading solution. And we'll move to the manipulator here so we can see the nuclei quite clearly. Change the focus. Okay, so there's the embryo. The zona has already dissolved. You can see that the zona is gone. So bit by bit you will see all the cells that will start breaking the cytoplasm. So you have to get a solution. So we just now have to gradually wash off and lyse the cells by releasing spreading solution. Okay, this can take a bit of time, and especially here we've got a whole embryo, so the cells don't all lyse at once, they lyse at different rates. Okay, so just kind of, or you'll be dealing with single cells, so it'll be much easier to track the progress of the lysis. Once they start lysing, they all go one by one. Okay, you start to see them. Now they'll go one by one, and you'll see the nucleus float out. Because the cytoplasm is a bit more granular and grainy, and more so in the mouse rather than humans, it will take a bit of time before you can see the nuclei clearly, because the nucleus is embedded in all that cytoplasm, the grainy cytoplasm. So as soon as that granularity washes out, you'll see the nuclei more clearly. So let's try and focus on different planes. Yeah, can you see the nucleus there? Yeah?
Oh, yeah, it's
Yeah?
good.
That nucleus there? And you'll see on different planes, you'll start seeing the nuclei. Can you see a nucleus there?
Yeah, yeah.
Can you see a nucleus there?
Mm-hmm.
Yeah?
Mm-hmm.
Now I must warn you, mouse nuclei are much more clearer than human.
Oh.
So it's kind of, I call it that it's the magic picture. When
Okay.
a lot of embryologists in my lab don't know how to spread because they can't see nuclei
Yeah, okay.
very clearly.
Can you show me?
Where is this?
Again?
One,
Yeah, okay.
yeah,
Yeah.
two,
Yeah.
Yeah, okay.
three, something maybe coming up. You'll see, as the cytoplasm washes out, you'll see it much more clearly. Now, just for spreading purposes, this level of cytoplasm is not acceptable. You have to gradually wash off this cytoplasm. If you have your nucleus sitting in a meshwork of cytoplasm, that is going to affect the fish signals.
Okay.
Okay? You need the nucleus nicely washed away from cytoplasm so that the fish, the probes can anneal to the nucleus or the chromosomes. Okay? The success of fish is dependent on spreading to a certain extent because you need to kind of make the nucleus very nicely available to the fish probes. Okay?
Can we see the nucleus again, if you please?
There. One. Yeah? Two. Three. Four. Maybe five. Yeah? Can you see? So now is to gradually wash out the cytoplasm.